And there's a lot of talk about the technology trends behind 5G technologies, but what about the human factor? How will usage data for wireless technologies influence the way we develop and deploy 5G technologies? John Gant, director for the Center for Digital Inclusion at the University of Illinois, is here to tell us how we can determine what the end user's needs are. Scott McGaldy, senior research scientist, technical development and strategy at Sprint, is also here to tell our viewers how to deliver that technology. And next to me is Bob DeFazio. He's research fellow with InterDigital Labs. He's going to tell us what technologies are in the research phase that will ultimately feed the market's hunger for next generation wireless technologies. And panelists, welcome to the program.
Thank you.
Thanks for being here. Of course, we just came off TIA's 5G symposium. John, I know you gave a presentation, Scott as well, and Bob DeFazio, thanks for being with us today.
You're welcome.
John, I want to get your take on the 5G symposium. Just start the show.
Oh, it was great. Good mix of folks from industry and both the operators and manufacturers and that type of thing. And then there were other stakeholders there as well too, talking about human factors as well. So it was very good. Really enjoyed it.
John and Scott, you talked about in your presentations, at the very top of your presentations, about the drivers for 5G technologies. Bob, I want to start with you on this question. First of all, what are those drivers, and will industry meet the consumer demand for what those drivers are in fact?
Well, there's a number of drivers, and one school of thought is build the capacity and they will come. But I just want to point out there are two other things besides capacity. One is latency, and another one is what I call the perception of mobility, because data is a little bit different than voice. And so it doesn't have to be quite as seamless as voice, but from a user who's using a data application, they have to perceive that it's the same. Now, in terms of the applications, it may be trivial, but we all do believe video is the first driver, and there's lots of room for, providing more capacity to support video. Other than that, all sorts of other applications, from augmented reality to virtual reality to machine to cloud computing, all of which it's really hard to put a number on them. But I think from the collection of them, we're all comfortable there is going to be a large demand for capacity. And then finally, the one thing we keep in mind a lot in our research and development is this has to be delivered in a cost-effective way. So we have to come up with technologies that can be deployed inexpensively and keep the cost per gigabyte down so that the average user can afford these services and the operator can afford to deploy them.
John, you had an interesting presentation, and part of that presentation was talking about when the inflection point is of when we realize that we need 5G or fifth generation wireless technologies. Can you forecast that for us? Or?
First of all, we've gotten really comfortable with our mobile devices as a consumer, and then the folks providing these are really starting to understand the marketplace better and the types of things that we like to do. I think consumers are getting more comfortable with things that we could do better in 5G, but right now, the fact that we're getting comfortable using data that comes from a lot of different places and using that in our devices. There's some small experiments and things that we're doing right now that we can learn from as well. And I think it's going to be a matter of when there's just more applications and more opportunities just to try, some new and different things as well.
Do you think some users' expectations have changed? Instead of waiting until they get home or to a library to find information, that now they have the expectation of, I need information, so I have to have something to satiate that request? Is driving some of this?
Yeah, I definitely think so, because the fact that we're seeing people that go from 2G and 3G networks now to 4G networks, and understanding that you can go find information when you need it. I mean, that's the whole beauty of mobile, is that I don't need to wait to get to a desktop at home or go to a library or school, that I can just be anywhere. Even on, like here today, break at lunch, question came up, you get your phone out and you can answer your questions. And the response time now is so much faster in terms of retrieving information. The way in which information is organized out there for us to use is so much better than what it was before. And then we see greater use of multiple media platforms to provide information and to do it in such a seamless way. And I think that's really driving it as well too. And I agree with you. I think that really sets the platform for us to be able to think about this next generation as well.
Bob, you said build the capacity and the applications, technologies will come. Scott, I want to ask you this. Is it all about capacity, or is there another layer or new way of thinking about it?
Well, no, capacity is always going to be an issue because the more people that are going to be asking for this type of service, this information, you're going to run into capacity constraints. But in addition to that, you have to worry about coverage. You have to be able to give them that information wherever they're at. We've initially designed a lot of our systems here in the U.S. for mobile coverage, so we had the streets and roads. Then we started covering to the edges of buildings and walkways. Now we're starting to cover into those buildings, into public transport systems, and that requires a whole different level of thinking and network architecture that has to be addressed.
Yeah, the whole build out of small cell networks, we think a lot about that, and it seems almost unnatural to have LTEA, the evolution of LTE as the coverage technology, and then introduce the small cell technologies. We talk about millimeter wave technologies in order to provide that ultra dense deployment and ultra high data rates, yet there needs to be that fallback to the basic coverage technology, so we can't throw away the older air interfaces. We need to build on them.
Exactly. And then we also have difficulties once we start to deploy those smaller cells to get that coverage in there. So we have to figure out how to get that information back to the network somehow. Building backhaul with fiber or with copper can be a cost prohibitive type of issue. So looking at new technologies such as millimeter wave to take on some of that load of backhaul will probably help us for 5G. So millimeter wave has the promise of not only being a solution for some of our coverage issues, it gives us a secondary way to get that information back to the central core.
Yeah, and millimeter wave, one of the nice things about it is there's lots of spectrum available. It's highly directional, which is just perfect for backhaul. And you could build low-cost equipment.
Small devices.
Small devices, evolution of WiGig technology, which already have low-cost mass-market technology. And you come up with a hybrid backhaul that has a collection of fiber connections and wireless connections that gives you the reliability you need. Mesh them so that there's redundant paths. It's a very promising way to get these small cells out there.
Yeah, during the talk today, we talked about this relationship between trying to build out more fiber as well too, and even recently as yesterday there were some additional comments out of the FCC saying, let's do more to build out these municipal fiber networks as well. From your points of view, how does that help thinking about building up for 5G?
Well, I think fiber is great, and certainly the goal is to get to fiber as quickly as possible. But there are really two issues we see with fiber. One is no matter how dense you make it, it's not going to be everywhere you want to put a small cell.
Right.
And second, there are costs associated with connecting to fiber, right? I imagine there are monthly costs, and I'm told they can get substantial. So if you're just trying to make a very, very dense deployment, and you can provide the backhaul capacity with, say, 2 out of 3 of the nodes of wireless backhaul that jump to the fiber point, all of a sudden that can make these small cells much more cost effective than having to pay a tariff to, for fiber connectivity at every single point.
Right. Good point.
John, in your research, you talk about finding out what the consumer needs, what their usage is for data, and then kind of reverse engineer from there.
Yeah.
What are your target groups for 5G research right now? Tell us more about that.
Well, in a number of different areas. One is the individual, and just trying to understand what their needs are and what are those conditions that they'll accept and use technologies like 5G. We're learning a lot from looking at broadband deployments and then wireless deployments in that space. So it's all about trying to understand the individual and how they see these types of technologies fitting with their lives and what value it may add to their lives, whether it's for social things, staying up with family and friends, or with trying to take care of your family with schoolwork with your kids, or healthcare needs, staying connected to your doctor, and things like that. So we've been looking a lot in terms of that user acceptance and thinking about all those different things that need to be in place. And the second thing to think about too are what needs to be in place at the schools and libraries and other important institutions in your community to help you use the technology and so forth. And then the third thing is the age-old question: what are the right price points, for this? what are the right price points, and then what types of service are people willing to pay for as well to meet their needs as well. So.
Scott, how wide is the gap between what John is talking about as far as what the consumer wants and needs and what the industry can deliver from an operator's perspective?
In some areas, it can be pretty wide. In other areas, we are meeting the needs of a lot of customers because we're really still at the initial stages of doing a mobile wireless data infrastructure. It's really only been with 4G that we were able to finally bring the concept of really pushing a wireless data pipe to a user. So they're just starting to use this, and they're pretty happy if they have connectivity at this point. So we went beyond 3G, which was still pretty focused on voice at that time with a little bit of data. 4G is really more about data, and I think 5G is where we really build on that, and that's where we're going to start to see this being used differently. I think the challenge is going to be are those users evolving faster than we're evolving our networks? The big challenge is that the bigger the pipe you give them, the more they suck data out of your network. And we've given them a big pipe. They're starting to use that. We're having to offload users from macro networks into smaller networks. So that's been a huge challenge as to how to manage that properly.
John, is there a use case or example you can give us as to what your research yields as far as consumer data usage?
Yeah, there's a couple. One is in the area of, in terms of telemedicine. There's a lot of research just trying to understand what the consumer is going to feel comfortable with in telemedicine, sort of patient-doctor type of relationship. So we've been seeing research that looks at improving the quality of telepresence types of tools to the point of looking at 3D types of platforms and looking at trying to understand how to make it so a person won't feel sick, physically sick. With 3D you have to worry sometimes about this feeling sick from the technology. But then also just what makes people feel comfortable. And then there's other work that goes beyond trying to look at ideas of teleimmersion, where you have a relationship with the patient through a virtual space, and you can actually move devices like with an exoskeleton and things like that. So there's some work being done there. There's other work being done looking at low latency. For example, you've got instances where you might have an orchestra in one place and a dance troupe in another, and they're all working together in sync, all through this to try and look at models of reducing latency as well, and so forth.
John, do you see any difference in the mix in indoor and outdoor data as we go towards 5G?
Oh yeah, significantly, because these examples are in studios that are like
Right.
this. I mean, we have them on our campus. We've got these cave environments, which is highly controlled. But then all of a sudden, when you get out into the outdoor space, there's so many other factors that are data you're capturing from the outdoor space that you have to take into account. So I think it's a very large difference in it, because I know in fact when they were running some of the pilots, it's become challenging when they go to an outdoor setting to try and do this, to actually work with a real device, like a real mobile device to interface this when it's in an outdoor setting, because there's so many other factors that impact the quality of the network when you're outside versus being in kind of a controlled environment that's been optimized, to get a high quality mobile network.
What about the high-speed mobility? When do you think that'll come in as an early requirement for 5G?
Yeah, because these examples are one where people are pretty much standing still.
Yeah.
But I definitely agree. I mean, Scott, you had a really great example of talking about in Shanghai with the maglev train.
Right.
And once you get up over a certain speed, wireless is it doesn't really hold up anymore as well. And I think that's going to be a very high demand right now because we are so mobile and we want to do it. When I look on campuses, for example, or even in cities, you see so many people with their devices. How many times have you seen somebody skating or on their bike and they're on their phone at the same time? We can't do it in the car, but yet they'll do it on those devices. That kind of reveals our mobile nature as well. So I really think that's going to be a big problem.
I wanted to go back to something when you were talking about the difference between the indoor and the outdoor data usage patterns. I don't know if you've looked at it or if it's even real, but is there clustering when they're outdoor? You get people outdoor, they're having a different data behavior, but is there a social interaction where maybe there's a cluster of people doing the same type of thing and maybe a short ways away, a cluster of other people doing something different?
Yeah, well, last weekend, in many towns around the country, in the springtime, you see a large number of outdoor events. It's a great way of looking at sort of people's behavior with mobile devices now, whether it's the start of baseball season or marathons that are being run or spring festivals and things like that. We've been to a few events where you do see sort of clusters of people, and the device, their mobile devices is very prevalent. They're sharing information, maybe doing disparate sorts of things, but yet they're all sort of clustered together. I would imagine it's a big network management issue of how do you quickly and dynamically shift the demand or shift network resources to make sure that you can provide a good quality service, in that type of instance as well.
Scott, you said your goal, one of your goals and aims is to make wireless usage easy enough that your grandmother can use it. Yeah. Can you give us an example of how you're doing that?
Well, one of the things that's been happening a lot with 4G data is that we offload people to Wi-Fi when they go indoors where there's Wi-Fi coverage. Having them on a macro site is a stressor on the network, so we can relieve some of the stress. We can react to people not being mobile. But to get people onto Wi-Fi, it can be rather challenging. They have to know what Wi-Fi is, which is a challenge right there. Then they have to open up their device. They have to find a Wi-Fi access point. They'll have to make a decision about what information they see about that SSID, if it's one that they think they can get into, and if it is one they can get into, do they have the proper credentials to get in there? Is it trustworthy? This is a lot of interaction for someone to do, and as a lay customer, they may not know all these questions to ask or know exactly how to do that. So their reaction might be to turn off Wi-Fi capability, and that keeps a stress on the network. So one of the things that we want to see happen and that we're starting to work towards is doing automatic Wi-Fi offloading, where we can direct the user to a Wi-Fi access point if we know the location they're in, we already have pre-knowledge of that Wi-Fi access point, and cause them to go over there so that they don't even realize that it's happened. We can continue on the session that they're operating. This makes them happier, it relieves the stress on the network, which makes us happier. So we're at the first steps of really starting to do that now in networks, and that's
actually
going to be a
very
big area.
Interesting technology. The whole idea of smart access management and making the connection managers much more intelligent, and some interesting questions come up as to where are the policies that determine what a particular device will do. Is it in the network? Is it in the user's device? Can the user override the device? Because as you said, you'll have some very sophisticated users who want control, and then you'd have users who just want it to work and don't really care whether they're on Wi-Fi or they're on a cellular network. And we've been working on a lot of technologies, both to make that seamless and also simultaneous. So some of the streams, perhaps a video stream goes over Wi-Fi, whereas a voice call or the control channels stay on cellular where you have reliable control over it. And that partitioning of traffic and the policies that determine how that traffic can be partitioned, are one of the things that are emerging now and are starting to become available in the market and will just grow with 5G.
Scott talked briefly at the top of the show about backhaul solution challenges. You talked a little bit about the access link. Tell me, Bob, about challenges in the standards realm. What are we seeing there?
Well, the challenges in the standards, there's a couple of things. One of the big challenges as we move forward to 5G are the frequency bands. When we look at small cells, we've talked about how millimeter wave is just perfect for small cells. Well, millimeter waves could be 28 gigahertz, 39 gigahertz, 60 gigahertz, 70 gigahertz. We need frequency allocations for this, and that's something that needs to be standardized almost internationally. And then at the same time, there's a lot of technology that can build the millimeter wave access down to the device. But again, there's a standards pipeline that will go through 3GPP, first as a study item, then as a work item, and then deployment, which is why we're targeting deployment, say, around 2020 timeframe to start to see this start to roll out. Backhaul, on the other hand, doesn't necessarily need to be standardized. So we can start to solve the backhaul problem with some existing small cell technology much sooner, maybe in the next couple of years.
And we do have some bureaucracies and lead times that we have to go through in a lot of this, because spectrum is managed through treaty with our neighbors in North America. We have to make sure that we've gone through all the regulatory hurdles with that, and that means we're really moving towards probably a WRC 18 with discussion on this topic with the ITUR. So 2018 is really the time that we would start to make decisions on this, but we have to start prepping now. We have to be doing all of our studies and getting into the ITU situation so that they can act and then the FCC can act. So there's a whole serial chain of events that has to occur.
You talked to Scott and John as well in your presentations about some solutions for better connectivity, better broadband usage. One of those was small cell technologies. What's the importance, Scott, of seeing small cell, not just the development of small cell kind of siloed, but within the context of the larger picture? What's the importance of that?
Well, I mean, small cell is providing an access in an area that we need it, so it can provide a lot of data in a small area to a few users. But being able to have, as the user drifts in and out of their coverage or changes their type of request, it needs to be an integral part of the network so we can provide the proper service to the end user. So it becomes not just an extension of the network, which is the way some people think of it, but it may be a supplement to the network to provide coverage in hot traffic areas.
Bob, I'm going to ask you this question. I'd like John to chime in on this as well to wrap up the show. What's your concern right now as far as available spectrum that's going to be out there for the industry?
I think in the lower frequency bands, the conventional bands, there's a lot of innovative work being done in spectrum sharing. And I think that has a lot of promise to start to address the president's requirement for 500 megahertz of more spectrum. Long term, I don't know if it'll meet the needs, and I think we're going to have to go up to millimeter wave bands and work hard to come to an international agreement and the standardization of the next generation access in one of the millimeter wave bands.
Definitely agree with what Bob's saying. And then to add to that, one of the bigger challenges for spectrum-wise is the fragmented spectrum that we have, trying to fit all of this together as we've asked for larger and larger channels. We just don't have the places to fit them anymore, so having to move up into millimeter wave bands gives us a new opportunity to address those needs.
Now, millimeter wave bands are to improve backhaul solutions as well.
Not necessarily. They can be there for small cell and backhaul. They could provide a medium area of coverage as well as what we're starting to see. We're really at the beginnings of trying to understand what the channels would look like to deliver these types of services. So there's a lot of work going on in trying to model the channels there. We understand them pretty well for point-to-point type of usage because that's what they've been used a lot. But to say a point to a multi-point terrestrial application is to be done.
But a lot of confidence that it's working. A lot of very smart people across the world have been working on it, and there's been a lot of measurements made to date.
Yeah, a lot of good measurements that's showing that this is really possible. And millimeter waves, not new to the industry, to telecom industries. It's new in a way that we're trying to apply it. So I think we're pretty comfortable that spectrum band is going to work for us.
John, millimeter wave technologies require high frequency spectrum bands, correct?
Yeah.
Are those available?
I think.
Or do you feel comfortable they're available?
I think they're working on it. Yeah, I think they're working on it as well too. And I think that certainly is a large concern. Is just trying to figure out how to really deliver, that and make it available as well too.
Well, it was an interesting conversation. I hate to cut you guys short, but we have only a certain period of time here on our show. I'd love to have all three of you back individually or as a group again.
Sure.
And if you can make it down to TIA's Network of the Future conference on June 3rd through 5th in Dallas, that'd be great. We'd like to see you there.
All right, great.
Thank you.
Thanks again, guys.
Thank you.
And for more on 5G technologies, you can register for TIA's 2014 conference once again in Dallas called the Network of the Future on, again, June 3rd through 5th. For help in registering, you can contact TIA's Director of Events, Tally Walsh, at twalsh@tiaonline.org. You can also go to tia2014.org and click on Register Now. So long.